Hello, I'm Rebecca the Maths Lady, and welcome to this video, which is the second of 3 videos about teaching algebra at primary school. And this video is all about missing number problems. In this video, I'm going to explain how we introduce children to solving simple equations using a part-part-whole bar model. I'm also going to talk about how we teach children to set up and solve simple equations of their own. And finally, I'm going to explain how we teach children to find pairs of solutions when there are 2 mystery letters. That topic is called solving equations in 2 variables. So if you don't need this video, here's your skip link to the next video, which is the final video in this series, which is all about formulae. Before you're ready to cover this topic, you need to make sure that you and your children have a good understanding of teaching and learning algebraic notation. So here's a link to that video if you've not seen it yet. So the first type of equation we might expect children to be able to solve is just a simple addition equation like this. A add 3 equals 20. And if you notice, A doesn't have to be a letter. It could be a star or a symbol of some kind. Sometimes putting it that way makes it more accessible to children, makes them less afraid of it. But it's just a mystery number we're trying to solve or puzzle out. Now, a lot of children will be able to see straight away that that's 17. But we want to teach them to use the formal part-part-whole bar model method to solve this. Remember, the part-part-whole bar model is different from the proportion bar. The proportion bar is used for fractions, decimals, percentages and ratios when we're finding fractions or proportions of amounts, and that has a controlled size for 1. In the part-part-whole bar model, we don't control the size of 1. It's really just another way of setting up an open number line. You could do bar modelling just with an open number line with numbers above and numbers below. It would work in the same way. But let's do this as a bar. We've got A is our mystery number, and we've got 3 that we know about. And we know that the total is 20. So that's A. We're trying to puzzle out A. So if we cut 3 off 20, that's going to leave us with 17 in this block. Therefore, A must be 17. And that visual model helps every child understand that question. So we'd expect your children to be able to work with this structure of equation where a mystery number add something, or you could do it the other way round. A number add your mystery number equals a given total. And if it was the other way round, we'd just put the number section of this block first. We want to extend them on into much harder numbers. So for example, this could be 312 and that could be 2086. Makes it much harder. And this could be a fraction. And this could be another fraction or a whole number. That's going to really stretch children to think and make their bar models help them. Then we want them to be able to solve puzzles with subtractions in. So we might do B subtract 8 equals 13. So B is going to have to be bigger than 13. B is big. This is B. And when we take 8 off it, we're left with 13. And with that bar model, we can quickly see that the whole of B must be 21. Because you've got to add those parts together. So B is a big number that when you subtract 8 from it gives you 13. And it's important to let children think just for themselves and puzzle with that question without the visuals too, and then make them connect their thinking to the visual model. This could have been C subtract 3 equals a half. C subtract 3 equals a half. So C, and when we subtract 3, the whole of that is C. That's a half in there. We can just do it with a single bar, it's fine. Therefore, C must be 3.5. And if you check that, and it's always a good idea to check it, 3.5 subtract 3 is a half. If you can teach children to check their algebraic solutions always at this stage, that would be awesome. Thank you so much. It will set them up in good stead for life. Okay, so we've covered addition and subtraction. Let's look at multiplication. 3d equals 21. 3d equals 21. So we need to revise that. That means 3 lots of d, and they're probably quickly going to know that it's 7. But let's draw it as a block diagram. What we're saying is that d, add d, add d, 3 lots of d is 21. And then we can divide out that 21. We can count off dots one at a time if we need to, but it'll help all the children confidently believe that when we get 7, add 7, add 7, it works. So 7 must be the right answer. They can do these by trial and error at this stage if they want. As long as they check their answer, are 3 lots of their answer 21? They are, we're good. And if they can draw a diagram, that's even better. And we could take this on to much harder numbers to practice division. You've got a 2-digit number here and a large number here. You'll be practicing your long division. You could easily have a decimal number and a whole number here. And you could have a fraction here and a whole number here. They're the different types of questions that children can work with. And if that brings you up against some maths that you or they need to revise again, you'll find a video to help you zoom in on the particular topic if you need one. Just go to authenticmaths.co.uk/videos and you'll find a list of all the videos to help you pick which one you want. Okay, division. So we could have f divided by 2 equals 14, and that would be much better written as f over 2 equals 14. It's the same thing. A division is a fraction. And now we need to draw a picture of what division is. So when we're dividing by 2, we're sharing fairly between 2 people or into 2 parts, and we want the size of each part. So what we're saying here is that f divided by 2 is 14, so 1/2 is 14. Therefore, the whole of f is going to be 14. Add 14 is 28. And you can solve any division in this way. Just divide your total block into the number of parts of the number you're dividing by, and you should be away and able to do it visually. And of course, as we're doing all that, we're doing some great consolidation work on our algebraic notation. And then we can move on to some composite equations. And by composite, I mean there's 2 parts. So something like 2a add 1 equals 15. So previously we would have had a add 1 or 2a. Now we've got 2 things going on. Let's draw that as a block diagram. So we've got 2a add 1 is 15. So a add 1 is 15. And then we can slice the 1 off. So that's going to become 14, add 1. And then we slice this in half, and each of those halves will have to be 7. Therefore, a is 7. The diagrams are a little more tricky with subtractions, but they are doable. Let's look at one now. So try this one. 3p subtract 5 is 19. So we've got 3 p's and a 5 missing. So that's going to be 5. That's going to be p, p, p. And 3 p's with a 5 missing is going to be 19. Therefore, if we add that 5 back on, we get 24. So 3 p's are 24. P add p add p is 24. And if 3 p's are 24, p must be 8. So it's solved. And what we're doing there is making a beautiful transition for children between visual part-whole models and algebra. And ultimately they won't need the part-whole model. They'll be able to see the numbers as letters in algebra and just play with them confidently. But in order for every child to be able to do that in the future, we have to make a really, really careful transition. So the next thing children need to be able to do is puzzle out how to write missing number problems as equations. So if I say to you, I double a number and that gives me 50. Double a number, that gives me 50. You can probably puzzle out that the number is 25. And that's how we want to start this topic, with really simple single-step calculation mystery numbers. So we'd write that as maybe 2m equals 50, and then we can go through the processes that we've just done, and they can use whichever letter they choose. I recommend against L. L is a problem because it looks so much like a 1, and my son's T's look completely like plus signs, even though he's doing A-level. So hopefully your children will write their D's better than he did. Personal gripe. And this becomes more useful when you get into multi-step problems. So I think of a number, I double it, I add 1, the answer is 333. I think of a number, I double it, I add 1, the answer is 333. Now some children will be able to do that in their heads, but if you write it as an equation, so I think of a number, I double it, I'm going to call my number Q, so 2Q plus 1 equals 333. Just being able to write down what I've just said as an equation, and then we can work through the steps we've learnt to work through with a bar model. So we'd have 2 Q's and a 1, totaling 333. If we knock the 1 off, that takes us down to 332, and then we can just focus on splitting the 332 in half to find a Q. So setting the equation up and then representing it with a part-whole bar model makes the question much more accessible to all children. So you can do a huge amount of work on this topic just with mystery number questions that you make up on the spot. But you will also come across this in other contexts. So for example, if children have done that the angles in a triangle add up to 180, and you're told that one of the angles is 60 degrees and another is 70 degrees, they could set that up as an equation. They could set it up as 60, add 70, add the mystery angle, let's call it Z, equals 180. And just writing it down like that, if they learn to see it in this way, then they can draw a bar model and then they can solve it. So you can do the majority of your work with mystery number questions, but it is good for children to get a little bit of experience of working on missing number problems and expressing them as equations in situations that they've worked on a lot already. You don't want to introduce a new situation in this way. Final part of this video is on equations in 2 variables, which sounds very scary, but it's really just about finding pairs of numbers that work in situations like this. A add B equals 10. A add B is 10. Can somebody tell me what A might be and B might be? So we could get A equals 2, B equals 8, and you can ask your students to come up with as many pairs of answers as they can. They can work in groups, they can be in competition with each other, and it leads to wonderful maths because they first of all work through all the whole number answers. They can work systematically, which they should be doing at this stage, and then you can say to them, but what about fractions? What about decimal numbers? What about decimal numbers to 2 decimal places? What about negative numbers? Can you do anything with negative numbers? So you can give credit for the most inventive answers and the most interesting answers. So there are some standard setups for these types of questions. One is where you're adding 2 mystery numbers. So that would be like that one, A plus B equals a number. And I'm just going to put question mark for any number. You can change the number and it changes the question. And to do a few of them, they start to see some patterns and everyone starts to get the hang of this, which is great. What about A subtract B equals a number? Explore that one. If say A subtract B is 3, what could A be? What could B be? Same questions again. Could they be decimals? Could they be fractions? Next one, AB equals a number, let's say 24. So A might be 1 and B might be 24, A might be 2, B might be 12, and so on. Could they be fractions? Could they be decimals? And then there's, if A divided by B equals 2, what could A be? What could B be? And you can extend the answers in that way. Can they generalise? And of course you can change that number as well to come back and explore these questions again. Lots of great lesson starters. This can go on for quite a while. And then the other type of this question are when A and B are on different sides of the equals signs. So you could have something like A equals B add 2. A is B add 2. What could A be? What could B be? So if B was 5, A would be 7, and so on. So your extensions for this topic, well, obviously there was lots in the last task. You can really stretch children, whatever numbers they come back with, and another one, and another one. Can you be more creative? Set up a competition between the children who are flying as to who can get the most answers and who can be the most creative, and get them to mark it themselves and agree who's won, unless you really have to intervene. The other extension I would suggest is that you go back to the equations with the part-part whole bar models and get children to invent their own that they can solve and set them for each other. Beyond that, all the usual things apply. You know your children, they should be doing lots of problem solving at this stage where they don't know which topic of maths it is. So it's wrong for me to always say, well, here's an extension for this topic. I need to remind you that it's great to chuck some problems at them where they're going to have to use totally different maths from the maths they've used in today's lesson. Otherwise, they'll just get into the habit of expecting it always to be the same maths, which is a really unhealthy habit. And of course, you don't just have to do extension in maths. If the child you're working with, you know, needs extension in other areas of their academic development, then they can do that too. And it is fine to get children working in groups, developing a collective culture and helping each other out as well. So your takeaways from this video are that we can now teach children to start to solve algebraic equations using part-part whole bar models. And we can do one-step equations with addition, subtraction, multiplication, division, and we can start to play around with two-step problems too. And then as a next step, we can give children verbally mystery number problems that have the same structure as what they've just done and ask them to set up and solve the equations themselves. And finally, we can play around with equations in two variables where there are two mystery numbers and children have to find pairs of numbers that work. And that's an amazing topic. You can do so much with that. If you have any comments or questions, please post them in the comments below. If you have any feedback, any worries, I'd love to know. I'd love to be able to help. If you have any criticism of this video, I need to know so that I can improve what I'm doing. I really value your constructive criticism. If you like the videos, please share them with your colleagues or anyone else you know who might like them. Let's build a world where every teacher really knows what they're doing when they're teaching primary maths and every child comes to thrive and be confident and creative with their maths. If you have any further questions, you can come and ask me live on Sundays at 9 AM British time. I hope to see you back soon for the final video in this series, which is all about formulae. Bye for now.